Hello everyone, can you hear me guys? If so, then please say yes. Hello, good evening Ayush. Okay, so this is the final revision of PNC and probability, and this is the final session of this series, okay, of quant. So last topic of quant of the final revision series. Second part of permutation, combination and probability. Okay, good evening Priya. Okay, so let's start with the session. As you know, in the earlier sessions, we only discussed the questions. So today we'll be doing the same thing. We'll be taking up the questions only and we won't be discussing any concepts. So let's start with the first question. Okay, so this is about me. I am Anurag Agarwal and I've been training students for CAT from last 15 years and I've been consistently getting more than 99.9 percentile in QA and LRDI section of CAT. This is where you can attend the previous sessions on this series. And we are also starting one more series. Okay, we will be taking up the questions from I am Indore. Okay, I am Indore has given a set of questions. So we will be taking up these questions. Okay, the timings are 5:30, 7 and 9. And we will cover QA, VARC, DILR, everything. Okay, and it will be, you can say this, or we will be covering all the important topics. So for that you need to either subscribe to our channel and or you can download the app. And this is about the CAT 2020 exam analysis on 29th of November, the day of the exam. The shift 1 analysis will start at 10:45 a.m., shift 2 at 2:45 a.m. and shift 3 at 6:45 a.m. Okay, so this is the first question. So 40 seconds for this. Good evening Anjali, good evening Basu, good evening Premlata. Okay, Bhaskar is saying D. Okay, Basu is saying C. Okay, Basu, I think you are correct. Answer is C. No, Aditi, I think it is C. So let's discuss this. It is given we have to arrange the letters of the word management. First and last letters should be similar, same. Okay, so if I look at this, so we have four set of similar letters. We have two M's, we have two M's, two A's are there, two N's are there. Okay, we have two N's and we have two E's. So we have four set of similar letters. Then we have G and a T. Okay. So can we say for the first and the last position we have four choices? Any of these four can come at first and last. So we have four choices for the first and the last position. Now for the remaining 8 there is no condition. So in between 8 positions can be filled in 8 factorial by 2 factorial into 2 factorial into 2 factorial ways. Let us say if I put m at first and last position, so I am left with these 8 letters. Out of these 8, these two are identical, these two are identical, and these two. So I am dividing it by 2 factorial raised to the power 3. So which is 4 into 7 factorial. Because this is nothing but 8. So it is 8 factorial, sorry, 8 into 7 factorial. So 8 will get cancelled out. I will get this C option. Yes, good Shruti, Ayush, good, Priya, good. Okay, so now I'm moving to the next question. Okay, try this one. Say you can ignore the options. I'm not very sure about the options. Okay, Pavitra is saying it is B option. Okay. Premlata is saying D, Shruti is saying B. See, I have told you guys that options, all four options may be incorrect, so don't focus on options much. Okay, so let's check this. See, it is given there are 5 identical dice. I need to find the number of distinct outcomes. Okay, so since dices are identical, all 5 dice are identical, so this outcome is same as this outcome since all 5 dice are identical. Okay, so this is same outcome, this as well as this. So can we say we have 5 dices and identical dices, so you just need to apply the whole number solutions. See, let me explain you this equation. A represents, if I say A represents the number of times 1 comes, B represents the number of times 2 comes, C represents the number of times 3 comes, and so on. D represents the number of times 4 comes, E number of times 5 comes, and F the number of times 6 comes. The only thing that will matter is these numbers are appearing how many times, and it will not matter on which dice they appear. Okay, since we have 5 dice, so any of these numbers can at most come on all 5 dices. Okay, and so I just need to find the whole number solutions. A, B, C, D, E, and F are all whole numbers. So just apply the formula for that. So which we know is 5 plus 6, C, 6 minus 1. So it is 11C5, which is the answer. And I don't think any of these values satisfy that. 11C5, I think, is this. So none of the options, let me check this. So it is 6 into 7, 42 into 11. 464, okay, 42 into 11 is 462. 462 is the correct answer. Is this clear, guys? Are you guys able to understand this? Answer is 462. See, the only thing important is, are you guys able to understand the equation that I have written? Because rest is simple calculation. Okay, Basu says yes. Very good, Basu. Okay, Ayush is asking me to repeat this. Okay, Ayush. See, Ayush, what I am saying is A represents the number of times 1 appeared. Similarly, B represents number of times 2 appeared. Okay, so let's say if I roll 5 dice, so this is a possible outcome. I get this. Okay, in 4 dice I have 2 and in one of the dice I have 1. Okay, since dice are identical, so it will not matter on which 4 dice I have 2. Okay, since all 5 dice are identical, so this is same outcome as this. Okay, so if I look at this, so in this outcome, if I look at this outcome, so here B is 4. Number of time 2 appears, we know it is 4 times, and A is 1, and rest of the number is 0. So A plus B plus C plus D plus E plus F should be 5. If I say 2 has appeared 4 times, 1 has appeared 1 times, and rest of the number would definitely appear 0 times if this is the scenario. Okay, if we have, let's say, this outcome 3, 3, 2, 2, 5. So that means C, which represents the number of times 3 has appeared, this is 2. Number of time 2 has appeared is again 2. Number of time 1 has appeared is 1. And number of times 4 has appeared, which is represented by D, is 0 in this case. Number of time 5 has appeared is 0. Number of times 6 has appeared is 0. Okay, so this is the meaning of A, B, C, D. And the sum should be 5. And any of the number can be present 0 times as well. So that is why we are applying whole number solutions. I hope all of you know how to find whole number solutions. So these are whole numbers. So that is why I am applying the concept of whole number solutions, which is 5 plus the number of variables, C, the number of variables minus 1. So which is 11C5. And if I solve this, I get 462. Is this clear, guys? See, if all 5 dices were distinct, then it would have been a simpler question. Okay, for each dice there are 6 outcomes possible, then it would have been 6 raised to the power 5. Okay, so now I am moving to the next question. Okay, so 330 is not the correct answer. All options were incorrect. Try this. In 330, they have applied the natural number solutions, so which we know is not valid in this case. If I assume that each of the number will be present once, so then you will get 330, but it is not a possibility. Now please be careful. I need to find distinct values. Can the area of the rectangles take? So that means 1 into 6. If I take breadth as 1 and length as 6, I'll get the same area as 2 into 3. So this is same area as compared to this. So I need to find the distinct values of the areas of the rectangles, not the distinct rectangles. 1 and 6, 2 and 3. These are two different rectangles. But if I calculate their areas, तो दोनों का area तो same है. आपको distinct values of area find करना है. Mayank, first dice can take 6 values, second can take 5. It is not this case. Okay, the first thing is dices are not distinct. So I will not differentiate between first dice and second dice. Okay, and second is, it is not about, the question is not this, that each dice should have a distinct outcome. It is about the distinct outcome of the set of 5 dices. हर डाइस का दूसरे डाइस से डिस्टिंक्ट होना जरूरी नहीं है आउटकम. पांचों को एज ए सेट देखो तो कितने डिस्टिंक्ट आउटकम्स पॉसिबल है. Okay, since I have not got any answer. Okay, Paras has given one answer. Okay, Paras. Okay, so let's discuss this question since I have not received this many answers. Only one student has given the answer. Terran has given 6. Okay, Terran, let's check this. See, since it is a this board of 6 into 6 dimension, so can we say length can be anything from 1 to 6? Same is true for breadth also. Okay, so if I consider those rectangles which have distinct length and breadth, so out of these 6 values I need to pick one for length and one for breadth, which can be chosen in 6C2 ways, that is 15 ways. I have taken a distinct value of length and breadth in this case. Okay, I have not taken those cases where length and breadth are equal. Now I will get 6 cases when both length and breadth are equal. They can be 1 each, can be 2, can be 3, can be 4, 5 and 6. So 6 cases. So this is the second possibility. First possibility, when length is not equal to breadth, so I get 15 and 6. So total till now is 21. Now I need to subtract those cases which is counted twice. So if I look at this case when length is 6 and breadth is 1, so this area is same as when breadth is 2 and length is 3. So this is counted twice. So I need to minus 1 for this, subtract 1 for this case. Okay, similarly 1 into 4, this is same as 2 into 2. So this is also counted twice. I need to subtract this. Okay, then 2 into 6 is 4 into 3. So this is also counted twice. So these are the 3 cases that are counted twice. So I need to subtract these 3 cases. So answer is 18. Okay. You can count this manually also. This will not, counting manually also won't take much time. See, if I take breadth as 1, let us say breadth is 1. So length can be anything from 1 to 6. So this is 6 cases. I'll get 6 distinct values of the area. If I take breadth as 2, then I cannot take length as 1 because 1 into 2 is same as 2 into 1. Okay. Then 1 into 4 is 2 into 2. I cannot take 2 also. So I'll have to start with 3 also. I cannot take 1 into 6 is 2 into 3. So I'll have to start with 4. 4, 5 and 6. So I'll get 3 cases. If breadth is 3, 1 और 2 तो वैसे ही नहीं देखना है क्योंकि 1, 2 आपने सॉरी दिस 1 and 3 आपने ऑलरेडी काउंट कर लिया तो 3 और 1 नहीं करोगे. So let's start with 3 into 3, then 3 into 4. Okay. So 3 into 4 is same as 2 into 6. So again I'll get 3 cases. If breadth is 4, length can be 4, 5, 6. 1, 2, 3 तो ऐसे ऑलरेडी काउंट हो गया है. 1 into 4 काउंट हो गया है. ओके. 2 into 4 काउंट हो गया है. So वो तो काउंट नहीं करना. So I get 3 more cases. Then take breadth as 5. Length can be 5 or 6. If breadth is 6, length can be 6. So either you can count this manually or you can apply this logic. But here you have to be careful while counting these cases. The cases which are being repeated. Is this clear guys? आप काउंट कर सकते हैं या फिर लॉजिकली भी सॉल्व कर सकते हैं. So I think there is some problem with the chats. I am not getting any responses. The last response I got is from Ayush, and I think it is 2-3 minutes back. In fact, 4 minutes ago. Yes, are you guys getting this? So if yes, then please type yes so that I can understand you are understanding this. I get to know that you are understanding this and I can move on. Okay, Dimple is saying yes. Okay, Dimple. Okay, so let's move to the next question now. Okay, try this question. Yes, I have not got any answer till now, so I am moving to the explanation of this. Yes, Ayush, Darren, Paras, any answer? Priya? See, this is one of the easier questions, so let's discuss this. From a deck of cards, 2 cards are randomly selected. We need to find the probability that both cards are of same color but different ranks. So we have 13 different ranks: King, Queen, Jack, 10, 9, and so on till A. So we have 13 different ranks. Okay, and we have two different colors, 26 red cards and 26 black cards. Okay, so the probability of picking first card is 1. Since out of 52, I can pick any of the 52 cards. So first card can be chosen in uh, 52 ways out of the total 52 ways. So the probability of the first card is 1. Now let us say first card is 7 of spade. So if first card is black, that means I need to pick the second card, and that should be black also. So I need to pick one of the remaining 25 black cards. Now it is given it should be of different rank. So out of these 25 black cards, I cannot pick 7 of club. That means of same rank. So out of these 25, I can pick any 24 cards out of the remaining 51 cards. So this is the answer. That is 8 by 70. Is this clear, guys? Yes, Taran, Ayush, are you guys getting this? Okay, so let's move. Okay, Badra is saying, please explain again. Taran, in cards, we have 13 different ranks. King, Queen, Jack, 10, 9, these are ranks. Okay, Badra, see, there is no condition on the first card. The question says the two cards should be of same color. Okay, so that means the second card will depend upon the color of the first card, but I can pick any card as my first card. Okay, Badra, I can pick any of the 52 cards as my first card. So probability is favorable ways by total ways. So for the first card, the favorable ways is 52 and also the total ways is 52. Paras, see, since I have taken the probability of first card as 1, so I don't need to make cases for black cards and for red cards. Either I can make cases. If I say first card is red, so probability becomes half. अगर आप black और red के लिए करोगे अलग अलग, तो first card अगर मैं बोलता हूँ black है, तो उसका probability half हो जाता. फिर ऐसे ही first card आप red लेते, उसका probability भी half हो जाता. तो half और half add होके यही आता. So that is why I'm not considering the color when I'm picking the first card. So I'm saying the probability of first card is 1. I can pick any of the 52 cards as my first card. Now, out of the remaining 51 cards, so for the second card, these are the total ways. Okay, now whatever be the first card, this is just an example to explain. Whatever is my first card, there would be 25 cards, more cards of the same color. Since we have 26 red or 26 black, so whether I pick a red card or a black card, the second card, for the second card, I will have 25 choices of same color. And out of 25, one will be of same rank, so I cannot pick that card. So barring that card, I can pick the remaining 24. So it is 24 by 51. Okay, so now I'm moving to the next question. I hope you guys have understood this now. Okay, try this. Okay, very good, Rishabh. It is 9 raised to the power 4. Six flowers arrangement. Okay, and it is given the arrangement should start and end with the same type of flowers. So there are 9 choices for this first, and there is only one choice for the sixth, because whatever is the first one, I should have the sixth one same as the first one. So there is only one choice for the sixth. Now 9 choices for this, then one choice for this. This third flower should be green, which is one of the varieties. So it is 1, then again 9 for this, and again 9 for this. So it is 9 raised to the power 4. Manoj, we don't have to find the probability in this. So 1 by 81 to answer nahi hoga. Okay, so let's move to the next question. Yes, Manoj, it is 9 raised to the power 4. That is 6561. It is not 1 by something. Okay, so let's move to the next question. Okay, since I'm not getting any answer, so I'm discussing this. See, it is how many numbers with 2 or more digits. So if I form 2-digit numbers, so since digits appear in ascending order, so can we say I need to choose 2 digits at least? So for 2-digit numbers, I can choose 2 digits in these many ways. And since the digits appear in ascending order, so that means there is only one way of arranging the number. If I pick 3 and 8, so I can write 3 and 8 only. I cannot write 8 and 3 because then the order won't be ascending. Okay, so I'll get these many numbers. If I form 3-digit numbers, so I need to pick 3 digits out of 9, which can be done in these many ways. And again, it can be arranged in one way only, because if I pick these digits, so the only way of writing them considering this condition is one only, that is 247. So in this, we just need to select the digits. So for 2-digit numbers, these many numbers are possible, 3-digit numbers, 4-digit numbers, and so on till 9-digit numbers. We cannot form more than 9-digit numbers if I have to fulfill this condition. Okay, and I don't think this condition makes any relevance or make any changes to this, makes any difference. So it is this, and we know NC0 plus NC1 plus NC2 till NCn, this is 2 raised to the power n. So this can be written as 2 raised to the power 9, and since these two terms are missing, 9C0 and 9C1 from this, so I need to subtract 9C0 and 9C1. So this is 512 minus 1 plus 9. So it is 502. I hope this is clear. Very good, Priya. Answer is 502. Manoj, it is 2 raised to the power 9 minus 1 and minus 9 also. Yes, Manoj, very good. Okay, so now let's move to the next question. Okay, try this one. Okay, Terran is saying 15. Terran, the question is how many different sets of tickets may they have had? I don't need to find the different tickets. I need to find how many different sets of tickets the 3% may have had. What you are finding is the different sets of different tickets that are possible. Okay, so let's discuss this. Delhi to Haridwar, there are 5 stoppages. So that means if a person boards from Delhi, he has how many different options? Okay, started from Delhi. So that means they have started from this point. So if a person boards at stoppage 1, so he has 5 different options. Either he can deboard at 2 or 3 or 4 or 5 or at Haridwar. So for this person, there are 5 different tickets possible. For this, it is 4 different tickets, then 3, then 2 and then 1. So total different tickets possible is 15. So and it is given these 3 persons have 3 different tickets. So out of these 15 tickets, they can have any of these, any 3 out of these 15. So I need to pick 3 out of these 15. So which is 15C3. Out of the 15 tickets, I need to select 3 tickets for these 3 persons. Are you getting this, Terran? Okay, let's move to the, okay. So I'm moving to the next question. Priya, what you are finding is the number of tickets, different tickets. I need to distribute these 15 tickets to the 3 persons also. Manoj, Priya, you both are doing the same thing. You see, this is a simple question. I need to form 5-digit numbers which are multiple of 9. So the divisibility rule for 9 is the sum of the digits should be divisible by 9. So we have 7 digits here and their sum is 28. So I need to pick 5 digits such that their sum is either 27 or 18 or 9. Even if I take the smallest 5 digits, we know their sum is 15. So 9 is ruled out. Even if I take the largest 5 digits, we know their sum is 25. So 27 is also ruled out. So that means I can have this as the only possible sum. Okay, the sum of the 5 digits can be only 18. It cannot be 27. It cannot be 9. So in other words, I need to remove or exclude 2 digits such that their sum is 10. If I need to select 5 digits, can we say I need to exclude 2 digits and I need to make this sum from 28 to 18. So that means I need to exclude 2 digits such that their combined sum is 10. So you can just have a look at these 7 digits. So either I can remove these 2, their sum is 10. So I am left with these 5 digits. And I can arrange them in any order. The sum will remain constant. So they can be arranged in 5 factorial ways. These 5 digits. Or I can exclude 4 and 6. So in that case, I would be left with 1, 2, 3, 5 and 7. So again, there are 5 factorial. So there are only 2 ways, either 4 and 6 or 7 and 3. या तो 7 और 3 को रिमूव कर दो, एक्सक्लूड कर दो, या 4 और 6 को एक्सक्लूड कर दो. सो टोटल जो नंबर्स होंगे वो 240 होंगे. 120 इस केस में, 120 इस. So total such numbers possible is 240. Is this clear, guys? Okay, now I'm moving to the next question. Okay, try this. Okay, make one correction here. It is not 215, it is 2 raised to the power 15. This is also 2 raised to the power 15 minus 1. And this is 2 raised to the power 15 minus 1. So A option, I am writing the options again. A option is 11 into 21 into 16. B option is 31 into 2 raised to the power 15. C option is 10 into 20 into 2 raised to the power 15 minus 1. And D option is 30 into 2 raised to the power 15 minus 1. See, there are 21 ways of selecting an apple. Sorry, there's 21 ways or 21 total number of selections of apples. 11 is the total number of selections for mangoes, and 2 raised to the power 15 is the total number of selections for the 15 balls. Okay, so if I consider this condition that at least one fruit, and these two are considered as fruits, and at least one ball is selected. So let us just focus on this condition, forget about this one. So total number of ways or total number of selections such that at least one fruit is selected. So this is the total number of ways of selecting fruits, and at least one fruit is this. Because this 21 into 11 includes a case when none of the apple and none of the mango is selected. So I've subtracted that case here. Similarly, at least one ball is selected, it is this. So answer is this. And again, I think all four are incorrect. Okay, all four options are incorrect. It is 21 into 11 minus 1. Is this clear, guys? The four given options are incorrect. The correct is 21 into 11 minus 1. Is there any confusion or doubt in this? Can we move to the next question now? See, I am not getting your responses, or the responses are a bit delayed, in fact a lot delayed. Okay, Taryn is saying why 21 not 20. See, Taryn, why we have 21 cases for apples? Okay. First thing is, apples we take them as identical. Okay, so either I can select one apple, or I can select 2 or 3 or 4 and so on till 20, or I also have the option of not selecting any apple. So that is why I have 21 ways. Either 0 apples or 1 or 2 or 3 till 20. So I have 21 ways for apples, 11 for mangoes. So this is the total number of ways of selecting an apple and an apple or a mango. Okay. See, what we are saying here is, if I have 3 apples and if I have 2 mangoes, so total number of ways would be 4 into 3, that is 12. Either I can have this 1 mango, or I can have 2 mangoes with 0 apples. Okay, if I select 0 apples, I can have these 3 cases: 1 mango, 2 mangoes, or 0 mangoes. Similarly, with 1 apple also, I will have these 3 cases. With 2 apples also, I will have these 3 cases. And with 3 apples also, I will have these 3 cases. So that is why it is 4 into 3. If there are 3 apples, so it means there are 4 possibilities. Because the option of not selecting any apple is also there. Two raised to the power 30 minus 1 for fruits. See, Manoj, we don't take apples as distinct. If it is given there are 20 apples, we take apples as identical. If it is given 15 balls, so balls can be of this. Balls can be distinct as well as identical. But in this question, it is given different colors. So that is why we have taken balls to be distinct. बट एप्पल्स और मैंगोज के लिए वो क्वेश्चन में मेंशन नहीं करेगा कि आइडेंटिकल एप्पल्स हैं कि डिस्टिंक्ट है. Apples we take them as identical, mangoes we take them as identical. Boys again he will not mention there are 20 distinct boys, because boys by default are taken as distinct. Okay, try this one. We need to select three members. Okay, and out of the three members, we should not have one complete couple. So can we say if I ignore this condition, so I can select three members out of eight. There are four couples, that means eight members. So this can be done in 8C three ways. Okay, which is 56. Now let us say we select one couple and a member and one more member. If I do this, so there is four ways of selecting a couple since there are four couples. Okay, and out of the remaining three couples, that means six persons, I need to select one more. So this can be done in 24 ways. So this is total, and this is the ways when we are selecting a couple. So difference of these two will give us the cases when no couple is selected, no complete couple is selected, which is 32. 56 is the total ways of selecting three members. 24 is the ways when we are selecting one complete couple and one member. So difference of these two will give us the ways when no complete couple is selected. Good Priya, good Manas. Manoj, answer is not 8 into 6 into 4. ऐसा आंसर नहीं है. Okay, now this is about the various subscription that you can have. Okay, 6 months validity is will cost you only 12.99. 3 months is for this. The earlier prices were 2000 and 1500. So this is the discount we are offering on occasion of Diwali. This is about the upcoming and ongoing courses. CAT 2021, a comprehensive course batch 3 has started on 9th of November. That means only a week back. Okay, and another batch for students preparing for non-CAT exams like IFT, TIS, CMAT, Maharashtra CAT. So it also started on 9th, and this is an ongoing course for GK. 18-month subscription for CAT 21 students. So if you are targeting CAT next year, you should go for this. This is the comprehensive course. Everything will be covered in much detail. Okay, and this is what you get in Gradeup Super subscription. You get access to all the live classes, doubt resolution, performance analysis, full this coverage of the syllabus, and all this is taken care by senior faculty members. And this is about the pool of faculty members that we have. Okay guys, so with this I end this session. Good night, take care, and best of luck for your exam.